nominal pi model. Right, I will draw this figure first. Let's say uh, basically it will take 1 minute. Okay, this is the nominal pi model. You can see the shape of this model is like a pi, right? And this is again for medium transmission line. Again, this is you can say it's a per phase model. Again, it's an approximate method. Again, the parameters are lump sum. Right. Uh, and you know this is apply for 100 kilometer to 200 kilometer. It will give the reasonable answer, right? And what is the difference between T model and pi model? In a T model, you can see the Z is actually divided Z by 2, Z by 2. Here you can say the admittance is divided at the sending end side and the receiving end side, right? So you can say the capacity effect is considered at the sending end side and the capacity effect considered at the sending end side. Where in a previous model, the capacity effect is considered a middle point, right, of transmission line, where you can see the admittance is considered here as a midpoint, where the impedance and the admittance are divided at ascending and the receiving side, right? Again, we apply the same thing. We apply the Kirchhoff's law and we try to derive the equation of ES and IS, sending end voltage and receiving end sending end current in terms of receiving end voltage and receiving end current. So let me start with the IL current. What about the IL current? So IL current is basically divided into two branch. One is the IR current and the second is this capacitive current. So I will write the equation for that. It's a IR plus what is the current in this particular branch, this particular branch. So it is the voltage multiply admittance. So we can say it is the VR into Y by 2. This is one of the equation of IL. Okay, what about the IS current? Similar way. So IS current is divided into two branches. One is the IL current and the second is this capacitive current. So I will write similar way. IL plus this particular branch, the current is, you can say, the voltage at this particular point multiply this admittance. So I will say it's Vs into Y by 2. Am I right? Now can I put this IL in this equation? Can I put this IL in this equation? So if I will put this IL in this equation, so I got the IS in terms of VR and IR. So I will just write this equation and modify it. I will put this equation here. So it will shows that it is a Y by 2 into VR plus IR plus Y by 2 into Vs. So what is the problem here? What is the problem here? You can see this equation is already calculated, but this is VR, this is IR, but this is Vs. We need to replace this Vs. Then and then we get the equation of Is in terms of VR and I. So we go for the Vs also. Now what about the Vs? What about the Vs? Vs is, here is the Vs. So this particular drop plus VR, it become Vs, right? So Vs is basically IL into Z plus VR. Now we have already equation of IL, right? We have already equation of IL. So I will put the equation of IL here, right? Because Vs is basically VR plus this drop, that is IL into Z. Now I can put the IL equation that we have calculated here, that I can put here, right? So what is the answer? VR I will write first, then this IL current, or sorry, Z is I will write first, and then I will write IL. So IL might be VR into Y by 2 plus IR, right? Simply I will write this equation here, that is your IL. Now simplify this equation. So it is VR plus ZY by 2 into VR plus Z into IR. So again I will simplify this equation. It is 1 plus ZY by 2 into VR plus Z into IR. Right, so I got the equation of Vs. So I will write this equation with box. So Vs basically Vs is basically 1 plus Z into Y by 2 into VR plus Z into Y. Right. Now I will put this equation here. So I can write the equation of Is also. Right. So I will do this same thing. Just remove this arrow. Now let's say Is is equal to, I will write same equation again, Y by 2 into VR plus IR plus Y by 2 into this equation. So I think it's a problem of space. I will remove this particular, right? Or I will I will write here. I think you can understand. Mm, I will introduce some space here. Right, so I will write it in this space. It is 1 plus zy by 2 into vr, this is this equation, vs plus z into ir. Now I will modify this is. So I will just simplify again. Y by 2 into VR plus IR plus Y by 2 into VR plus ZY square by 4 into VR plus Z into IR. Now you can see here, VR and VR, and here is also VR. So this y by 2 VR and y by 2 VR becomes y into VR plus again we have another term of VR, so it is z y square by 4 into VR plus I have the another equation for IR, so I have this I think this is 1, right? Here I think this y by 2 is multiplied, sorry, it's mistake, so it is y by 2 is multiplied because this term is also multiplied with this. So I have 1 plus zy by 2 into IR, right? And again I will simplify this term, so it becomes y might be the common, and we have 1 plus zy by 4 into VR plus 1 plus zy by 2 into IR. So this is the equation of IS. This is the equation of IS. So I will just put the mark only. So again we have the two equations, Vs and Is in terms of VR and IR. So I will write in a box in a matrix form. Vs Is is equal to, what about the Vs? It is 1 plus zy by 2 using this equation into z. And what about the Is? It is y into 1 plus zy by 4 into 1 plus zy by 2, right? And is into multiply with it is VR and IR. Now what about the ABCD parameter? Let's say, sorry, what about the ABCD parameter? So if we compare with above equation, so we have A equal to, this is like this, right? I am not writing, so it is not confusion. Now you can compare with this equation with this equation. So what about that, let's say a equal to, let's say, 1 plus zy by 2, which is same as B. And what about the B? B equal to Z and C equal to y in bracket 1 plus zy by 2.